Alright, so let's talk about how to do breadth first search. We were given an array and we want to find the shortest distance from some node. So what we're given is we're given an obstacle array. So an array that tells you whether each point is an obstacle or not, and then a starting point s. So the first thing we do is we set the distances to we build an array called a distance array, and we set all the distances to infinity. And then we're given the starting node, and that starting node, its distance to itself is going to be 0. And then what we're going to be doing is maintaining an array called a queue, and then this distance array. What we're going to return is this distance array. So I'm going to add that at the top. 7. Return distance array. So our goal is to build this distance array that tells you all the distances to some start node s. And so the first thing that we do is we put into our queue the value s. And then we're going to keep 2 pointers to the queue. The first one, current, is going to be the node that we're currently examining, and empty is the next spot in the queue that's empty. And so since the first one is going to be s, we're going to say current is equal to 1, and empty is 1 past that. So it's at 2. And we're going to go through this loop, and as long as there's a difference between my 2 pointers, because I'm going to be moving current down and extending empty, moving current and empty. As long as there's a distance between the two, I'm going to continue working till the very end. My current will catch up with empty, and there'll be nothing left in the queue to look at. So the first thing I do is I'm going to grab a vertex from queue, and so we're going to grab the current one, queue current. And then for each neighbor n of v, we're going to do a few steps. First, we're going to test and see, is this, so let's say if 7 is my value that I'm looking at, I'm going to look at its neighbors. The first thing I want to know is if they're an obstacle. So if n is not an obstacle, and the distance to this neighbor is less than my current distance, my node plus 1. So that's my distance of v plus 1. If that n, then what I'll do is I'll just set it. If that's true, then we'll say, hey, we can get there faster by getting there from our current node. The next thing we'll do is we'll say, well, I'm going to put that value into my queue. So I'm going to put n into queue, and then I'm going to increment my empty pointer. So empty equals empty plus 1. And then I'll say that and then I'll do that through here. And after I've done each of my neighbors, then I'll say, well, current is equal to current plus 1. And I'll keep on going until my empty catches up my current pointer, and then I'll return that distance array. So let's do an example where we start. And so I've already helped you out by setting all my distances initially to infinity. Then I want to say, well, let's assume that my starting node is 8. So I'm going to start with 8. So my first thing that I do is I set my distance to 8 to be 0. So it's no longer going to be infinity, it's going to be 0. I'm going to say my queue, my first part in my queue is going to be my starting point, which is 8. And then I'm going to say that my current, I'll just put a C here for my current, and my empty is going to be at 2, and I'll put an E here. I'm going to switch out for a pen, because it'll be a little bit easier to see. And now I'm in this main loop. That's where I'm going to spend all my time. I'll say, well, v is equal, what is my queue at current? So that's 8 right now is v. And for each neighbor, n of v. So what are my neighbors of 8? And I'll go in clockwise order, so they could be 3, this will be 9, 13, and 7. First neighbor I'll start with is 3. And first I say, well, is it an obstacle? It's not an obstacle. And if its distance, infinity, is greater than distance of v plus 1, so that would be 0 plus 1. Infinity is certainly greater. So I am going to visit 3 by starting at 8. And so I'll set my distance of n is going to be now 0 plus 1, so that'll be 1. And then my q empty is going to be n, so I'm going to add that here, because my empty pointer is pointing right there. Empty is equal to empty plus 1, so I'm going to put empty here now. And then I'll go to the next neighbor, which here is 9. 9 is an obstacle, so I can't expand that. So next I look at 13. 13 is not an obstacle, and infinity is greater than 0 plus 1, so I can visit it from here. So I can, so 13, I'm going to set its distance to be 1. I'm going to add that into my queue. Then I'm going to increment my empty pointer. And I look at my next neighbor. My next neighbor is 7. And 7 is not an obstacle. And infinity is greater than 0 plus 1. So we are going to visit that. My distance of this is going to be 1. I'm going to add 7 to my queue. Then I'm going to increment my empty pointer. Now I've done all my neighbors from here, so I'm going to pop out of this for loop. I'm going to say v is equal, then I'm going to increment my current pointer. So now my current pointer is pointing at 3. I'm going to grab that. 3 is my neighbor. I'm going to look at each of the neighbors of 3. So the first neighbor I have is 4. 4 is an obstacle. I can't do that. Next one is 8. The distance from here would be 1 plus 1, that would be 2, but 0 is less than 2, so I'm not going to add that in there. So the next one I look at is going to be 2, and it's not an obstacle, and its distance of infinity is certainly greater than 1 plus 1. So I'm going to say I can visit that one from 3. And I'm going to say its distance is equal to 2. And I'm going to put 2 onto my queue, increment my empty pointer, then I'll go up. 3 doesn't have any other neighbors. So I'm going to increment my current pointer. It's now pointing at 13. And so I'm looking at 13. I'm going to look at each neighbor of 13. I'll start above it. This is not an obstacle, but it's more expensive to visit there. This is an obstacle. 18 is not an obstacle, and infinity is greater than 1 plus 1. So I can visit that one from here. And so the first thing I do is I set its distance to be 1 plus 1. So it'll be 2. And I'm going to put it into the empty queue. I'll put 18 there. And then I'm going to increment my empty pointer. Ta-da! Next, I look at the next neighbor of 13, which is 12. 12 is not, it's not an obstacle, and it's cheaper to visit it from here. So I can set this value to be 2. I can increment, put it in here. This is going to be 12 here. Increment my empty pointer. And then I go up and I look at the next neighbor of 13. Well, we're done. It's done all 4 neighbors. So then I can increment my current pointer. And so I'm grabbing now, looking at 7. 7 up here. So I'm going to look above it because my current value is 1. It's not an obstacle, but it costs the same to visit it. So I'm not going to visit from 7. 8 it would be more expensive to visit than 7. 12 would be the same cost. So the only one that's left of my neighbors is going to be 6. 6 is not an obstacle. Infinity is greater than 1 plus 1. So we're going to go to 6 from here. And we're going to say that its distance is going to be 2. Its q is going to be value. I'm going to add 6 here, increment empty, and there are no other neighbors for this. And so I can increment my current pointer. This current pointer is now pointing to 2. And as I go through this loop, the only neighbor that's cheaper to visit is going to be 1. So I'm going to set this to 2, put 1 in here, move my empty value down here. There's no other neighbors, so I can go and increment current. The one that I'm currently looking at is 18. It'll have 2 neighbors that I can visit, so 13 has already been visited, but 19 is still infinite distance. So I'm going to visit 19. I'm going to change it to be 2 plus 1, so that's going to be 3. I'm going to put 19 into my array, increment my empty pointer. The next neighbor of my current pointer, 18, 17. That one's infinity, so I can visit it. And I'm going to set that one to be 3. I'm going to put 17 in here, increment my empty pointer. And you'll notice, we're expanding. There's quite a distance between C and E, but it's going to decrement now. So I've done all my neighbors of 18, and so I'm going to increment my current pointer. My current pointer is now 12. Look at my 12, go up. That's been not cheaper to visit, not cheaper to visit. 17 is not cheaper to visit, but 11 is, because it's still infinity. So I'm going to set that one distance to 3. I'm going to add 11 here, increment E. There's no other neighbors for 12, so I'm going to increment my C. My C is now 6. So I'm going to look at my neighbors of 6. This one's already been visited. There's nobody to visit here. That's cheaper to do, so I'll increment this. Now I'm looking at 1. There's no neighbors to 1 that can be expanded. I go there. Now I look at 19. Whew, 19 does have a neighbor I can visit. No, this is an obstacle, but 20 hasn't been visited. So I'm going to set 20. Let me set to 4. 3 plus 1. I'm going to add 20 here. Take my E and move it down here. And there's no other neighbors for it, so I'll increment my C pointer. It's now looking at 17. 12 is not easier to visit, 18 is not, this is off the board, but 16 I can visit. And so I'll say I want to go there. It's going to be 1 more than 17 was, so that'll be 4. I'm going to add 16 to my list, increment E, and then I'm done here. So I'll increment my current pointer. We're looking at 11. It has no neighbors to visit. So next I'll look at 20. Oh, I can visit a neighbor here. First I'll try 15. 15 infinity is, so we'll set that one to 5. We're going to add 15 here. Put my empty pointer there. And we're done with 20. There's no other neighbors 20 can do, so now we're going to expand 16. It doesn't have any neighbors. So now let's expand 15. 15 does have a neighbor 10 above it that hasn't been visited. We'll set that value to 6. And then we'll add 10 to here, increment our empty pointer. We're done with 15, so now we're going to increment our current pointer to point at 10. Oh, it does have a neighbor we can visit. We'll set that one to 7. And we'll add 5 here, increment our empty. And then there's no other neighbors of 10, so now we're going to increment current. It's pointing at 5. 5 is no other neighbors it can meet, so we'll increment C. And now empty is not greater than current, and so we can exit. And so we're going to return this distance array. Sometimes people also return these parent arrays, but you don't have to do that, because now if we're given the distance array, we can take any point. Let's say I want to know what's the fastest way to get from 15 to get to 8. Well, I go to 15 in my distance array, and I find it's the smallest number that's near it. What we're really doing is we're following the gradient. And so the nearest, the smallest number that's next to it is going to be 4. Smallest number next to 4 is 3. Smallest number next to 3 is 2, 1, 0. And so our path is just going to follow that gradient. So from the distance array, we now have the shortest path to S from any point in this whole distance array. Okay, this is well and good, and I'm sure you say, oh, I know this exactly, but I don't believe you. And so what I want you to do now is to do this on the second array that I've given you. And so I want you to go through this and fix that. All right, it's up to you. Do great things. Tell me about it. I'm going to pause the video here, and we're going to say that we want to start at S. And you can do it. So pause the video. It's your turn. Okay, I'm trusting you implicitly, and so now I'm going to do this, just so you can see how that's done. So we want to visit s is equal to 6. We've already set all the distances to infinity, and so distance of 6 right here is going to now be 0, and I'm going to set my Q to be 6 up here, my current is here, and my empty is 1 more. And so now I go into my array here. So I grab 6, look above it. Infinity is certainly more than that, so I'll set this to 1, and then I'm going to add 1 in here, increment empty. Look up to the right, that's an obstacle. Down below it, that 11. Infinity is certainly greater than that, and so I'm going to set its distance to 1. We're going to add 11 here, increment our empty. No other neighbors for 6. We'll increment our C. We'll look at its neighbors of 1. Nothing here. This one I can visit. So we'll set that one to 2. We'll add 2 in here, increment empty. And we're done with 1. So now we can go, we increment our current. We're now at 11. 6 is not cheaper to visit, but 12 is. So we're going to set its value to 2, and we're going to add 12 here, and we're going to increment this value. The next one we can do, infinity is certainly greater than 2. We'll set that value to 2. We'll add 16 here, increment empty. We're done with 11. So increment current. Now current, we're going to look at 2. There's no neighbors that we can expand. So now we'll look at 12. Nothing here, but I can go down here. And so I'll set that value to 3. And we're going to add 17 here, put empty there. And 12, there's nothing else we can expand. So now we're going to look at 16. 16, there's nothing that can expand. So now we're going to look at 17. 17, infinity is certainly greater than 3. So we'll set that to 4. And we'll add 18 here, increment our empty pointer. And there's no other neighbors that 17 expand. So now we're going to look at 18. We can expand that one to 19 because 4 plus 1 is 5 is less than this. So we'll set 5 here. We'll add 19 here, increment our empty pointer. Nothing else we can expand here. So now we'll go to 19. 19 we can expand above it. So we'll set this one. 6 is certainly less than that. We'll add 14, put our empty down here. We can also expand out to this side. So we'll add 20 into our list. Increment our empty. Now we're done with it with neighbors of 19. Now we'll look at the neighbors of 14. So first we go above it. Infinity is less than 7. So we'll say 7 there, and we'll add 9 here, and increment our empty. The other neighbor is 15. We can do that. So we'll add, this is 7, and we'll add onto here 15, increment our empty. There's nobody else I can add, so we're done with 14. Now we'll try to expand 20. I forgot to put my arrow there. So 20 has no neighbors that are left to expand. This next we'll look at 9. Oh, above it, this 8 is certainly less than infinity. So we'll add 4 here, increment our empty. We'll look over to our right, and 8 is also less than infinity. So add 10 here, increment there. And we're done with 9. And so we'll now look at 15. 15 has no neighbors that can expand. We'll look at 4. 4 has a neighbor that can be expanded. 5, so we'll set that to 9. And we'll add 5 over here, increment empty. Then we're done with 4. So now we'll look at 10. It has no neighbors that can be expanded, so we'll increment that. We'll look at 5, no neighbors, and so we've incremented C. And now C is the empty is not greater than current, and so we're done. All right, thank you very much. That is breadth first search, and just an example. That's what we're doing here. The only difference here is that I'm also adding diagonals, and I'm setting those to be the square root of 2 cost more. And so you can see it prefers diagonals, so we can take it. And again, we return this distance array, and then we can compute on that. Right. Thank you much. You have been wonderful.